know, you need to learn to study. You need to learn. I know it's hard to be like, I wish I could just give you one formula to do it, but it's impossible. You got to find your own way. I'm just looking for the best spot to do this, and I will do this on page 28, okay? So one thing that I need you to remember when it comes to tolerance, it is the range of acceptable values, okay? It makes sure the item is not too big or small. Basically, it gives a bit of a parameter there. Always think of this, folks, okay? There's always going to be a max, a maximum allowed. There's going to be a min. And usually, if unless otherwise stated, there's something called the nominal. What's the nominal again? Anybody remember? When I say nominal, we are looking for, that's our target. That's our target. Okay. So the tolerance, folks, let's make an arrow going from the top all the way to the bottom. This is what our tolerance is. So you got to remember that. And so sometimes they'll give you pieces enough to find, to start somewhere and go to the other one. Okay? So for example, what are the 4 ways of writing tolerance? I don't know if you remember that. I'll try here. Nominal, plus or minus, half of tolerance. Then there's max, plus 0, minus tolerance. There's min, minus 0, plus tolerance. And then there's the one that simply states the max and the min, like that. Stacks them like that. So all 4 of these are ways to state your tolerance. They all seek the same thing. Their purpose is to figure out, I can't go past this, and I can't go right in terms of the high side. On the high side, you can't go lower than this on the low side. They all seek to answer that. Four ways to state, I will say. 4 ways to state. And so let's say you get an example like this. Let's look at, I'm going to just go by my tire on my car. If somebody says, hey, the tolerance of the amount of air in my tire is right there, you should look at it and be able to fill in 4 crucial pieces of information. They're actually all found right in here. And this is what you should be able to answer. What is the maximum and what is the minimum? Okay. And the other 2 pieces would be, what is the tolerance and what is our nominal? Okay. Write that down. What's the max? What's the min? What's the tolerance? What's the nominal? Can I ask you to fill that in real quick? Put numbers down there for all 4. Let's pretend this is the exam. This is Wednesday. Would you be able to answer these 4 based on the numbers here? And I would think that you should be able to do at least 2 out of the 4. I would hope you could fill in 2 out of the 4 there presented to you. Go ahead and do that. It's okay if it's a 12. At this point, it shouldn't be wrong, but right now I want you to just try, see if you remember. You got it? Okay, max. Just read. To get to the max to the top, you'd go 50 plus 0. So you can't. That is the highest, indeed. Okay? The minimum pressure in my tire would be 50 minus 5. That's 45 psi. Okay? What's the tolerance? How do I find the tolerance? Remember, the tolerance is the difference between these two. So I will go max minus min. That's 50 minus 45. In this case, it's just 5 psi. That is the tolerance. What's the nominal? It's always, if there's a big number in front, that is your nominal. That's what we're aiming for. Ideally, we have 50 psi in the tire. You don't want to do too much, because what happens if you overinflate? Now it's a danger of maybe it bursting or yada, 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 right? And why is it so important that you collect these pieces of information? Because often you're going to be asked to rewrite. You're going to be asked to, what's the maximum? What's the nominal? They will ask you these things. I don't know which one they're going to ask you for, but if you just remember that given a tolerance, you can always collect these pieces of information, you're going to be golden, okay? And by the way, sometimes, I'll say this, when max min is given, if you get this format, then nominal is, here it is, nominal is going to be max plus min. You're going to have to find the average between the two. I hope you write this down. I think that should be on your study sheet. However, they often tell you that. We're assuming that the nominal is between the highest and the lowest. They'll tell you that quite often. But if they don't, here it is. I told you so, right? Because this one right here, this is the special case. This is the only one that doesn't explicitly tell us what the nominal is. All of these other ones will have a big number in front, all of these three, where you can just tell that's what my target is. Okay. The other ones don't. Okay. This was just a crash course overview. Let's answer some questions here. How many of you have done this one already? Like this one right here on page 27. You've already done it? Couple? I hope more than just a couple. Refer to the following diagram of a speedometer. State the precision of this speedometer. How do you know the precision? Anybody remember? Smallest increment. It's not 10, is it? What do you go up by? To go from here and then here, you're going to go up by 5 at a time. You're going up by 5 every single time. So your precision is 5. And you got to go with units because they're giving you the units, right? 1 mark. What's the uncertainty? This is a slam dunk, hopefully. Uncertainty is 5 divided by 2. It's 2.5 kilometers per hour. It's always half of my precision. I used up so much space on 27 on the next page, but that's okay. We'll make up for it. Let's go to the next one here. What does it say here? 1 mark, okay? 1 mark. So it shouldn't be too much to it. Johnny needs to measure 1 3/4 cups of water to make bread. Justify which of the following measuring cups is more precise. Which one of these two is more precise? A, I would agree with you. I'm just going to say why. From this marking to this marking is 1 cup. 1 cup, right? So precision is 1 cup on this one. Whereas over here, it's not going straight from 1 to 2. It's going half a cup at a time. Half a cup, right? So the precision here is half a cup or 0.5 of a cup. It doesn't matter. Justify. So this is good justification. You've told me what the precision is for each. And so smaller precision or increment, it doesn't matter. You can use either one. Smaller precision or increment, therefore more precise. If you're fueling up today, if you drive a car, look at the precision of your pump. Just try to think of it next time you fuel up. I won't tell you. You'll just have to look at it. Next. Two marks for this question. Jill buys a roll of wallpaper. She uses measuring device with a precision of 1 centimeter. They tell you that precision is 1 centimeter. To measure and cut a 95 centimeter piece, state the maximum length of the cut piece of wallpaper. What is this saying? It's saying this, that 95 isn't just 95. 95 is plus or minus something. Yeah. What goes here, folks, usually? It's the uncertainty, correct? We know what the uncertainty is because we know what the precision is. So we're going to divide that in half. 1 divided by 2 is 0.5. So now we know based on this scenario, using this device, we know that the piece of paper is 95 plus or minus half a centimeter. So the max obviously is going to be 95 plus 0.5. So it's 95.5 centimeters. If it had asked for the min, we would have subtracted. This is my final answer. Always remember that. Whenever there's a measurement, it's actually plus or minus the uncertainty. Next, state the minimum. Oh, they asked for the minimum next. Right? The minimum is 95 minus 0.5. That'd be 94.5. You know why they, in my opinion, why they broke this up into A and B? If you got this wrong, a common mistake is students saying 95 plus or minus 1. So then if you go 95 plus 1, that's 96. That's wrong. You would have lost a full mark there. But then you would have still received the mark here because you're basing your answer on previous answers, right? So that's probably why they broke it down into A and B there. Okay? So maybe this is for you for your study sheet. Sorry, let me try this again. A measurement can always be stated as measurement plus or minus uncertainty. Okay? Always. So the max is going to be measurement plus uncertainty. The min is going to be measurement minus uncertainty. That's probably worth adding to your study sheet. But just remember, how did I get that uncertainty? I went precision divided by 2 is what I plug into the uncertainty. If you don't know what P is going to be on the, just make sure you write precision. Okay, so all of these I would just add. If you still have room to on your study sheet, I would add all of this to my precision measurement section. Okay. Next page, 2 marks. You're with me still? Yeah. Just as long as you stay with me, I'll do this, right? Like I don't want you to like drift off and fall asleep on me. I don't mind helping you. You just gotta want the help, right? There we go. Page 29, or question 29, I should say, page 30. This question is worth 2 marks. Colin has a bucket marked in 1,000 milliliters increments. Okay, so highlight that. When you see markings and increments like that, it tells you that the precision is 1,000 milliliters. That's what that means. And he fills it with 4,000 milliliters of liquid fertilizer. So this is what's actually in the bucket. Next, what are we told? You want to remove 300 ml of liquid fertilizer. He uses an 1,000 milliliter container marked with 100 ml increments. Calculate the remaining amount of mixture that will be in the bucket and the format measurement plus or minus uncertainty. Okay, let's see what we've got here. This is the part where we talk about combined uncertainty. You should write this down and add it to your study sheet. Combined uncertainty. You go measurement plus or minus uncertainty plus, right? If you're adding, you would go plus or minus uncertainty of the next item that you're using, that you're combining. And this would continue on. Okay? And then you get total plus total uncertainty. That's one scenario. You can also get measurement plus or minus uncertainty minus measurement plus or minus uncertainty total plus or minus total uncertainty. You want me to zoom into that part? There you go. Plus or minus uncertainty. I will say this under this. Always, no, I would like to have it here on the slide here. Uncertainty, always add. You always add up your uncertainties, no matter if you're removing or adding to it. If you're removing, whatever you do, you always add your uncertainties. Okay, so these are always going to be added together, no matter whether you're removing or adding to the mix. You're always going to add. Okay, so that's what's happening here. In this case, we're removing from a bigger container. So let's put this to the test. I'm going to leave it up there. Okay, Roel, can you read that? Yeah, okay. So what's happening here is big bucket has how much? We're told, they're telling you it's 4,000 mLs of fertilizer plus or minus. What are you going to put next to it? Plus or minus what? What's the precision of the bucket? 1,000. So can I encourage you to right away next to that go and uncertainty therefore is half of it. The big bucket has an uncertainty of 500 ml. So you go back down here and you say, that is my big bucket. I'm going to subtract small container. And how much am I going to take out? How much do you want to remove? It says it in the question. 300 mLs. So we're going to go minus 300 mLs plus or minus. What is the uncertainty for the small container? I'll go up here. It told me that it was 100 milliliter increments. It's confirmed by the diagram. So precision is 100. Therefore, my uncertainty will be half of that. Always like that. Precision, uncertainty, half of it. Go ahead. So this will be 50 mLs like that. So we're about to get this done. This would be 3,700 milliliters plus or minus. We add, okay? This is a very good example of subtracting the amounts but adding the uncertainties. I'll say this, add uncert. And this is the remaining amount, this one right here. That's how much would remain. If they would ask for maximum remaining, you would add those two. If they ask for minimum remaining, you would subtract, right? You go this minus that. Good thing they didn't. That would have actually had to be a full mark on top of it. Okay. You're good? We want more? Please, more. Please. Let's do this one. So this is one that you would be tempted to leave blanks like, I don't know. I'm moving on. Please don't. Ralph is painting his living room with a custom color that was created at the paint store by mixing colors. He did not buy enough paint and needs to buy more. Explain why a degree of accuracy is needed when mixing additional paint to match his original color. You know that they're mixing paint, right? When you get the color, they're mixing different colors to get your color. What would you say here using your own words? I would maybe say, well, if the amount of the colors you are mixing is off, you will not achieve the desired color. That's pretty much it. We had one with sugar and cookies before. Well, if you add too much sugar, right, it might be too sweet. If it's not enough sugar, then people might not buy it because it's not sweet enough. It's something as simple as that can get you half a mark, if not a full mark. And trust me, if you have 5 of these embedded in a test, right, it adds up. What's 5 out of 77? That's 6.5%, right? So it adds up. Don't leave them blank. What do you think you need more help with? You need more precision measurement or trade? probability on this one? Let's do it. Let's do probability. Let's go find it. I told you, right? It's always it always is broken down into topics, so you don't have to guess which unit you're in. This is on page 8. Can I just say one thing? When you're in probability, read if it's saying probability or odds. Don't mix those up. I see that so many times. Okay? Good. Page 8, let's go. Question 7. 1 mark. So you know it's not going to be a whole lot of steps. Emerito has to write a math quiz at the end of every week. Each quiz is worth 10. His marks for the last 6 weeks were as follows. State the probability that a randomly chosen quiz has a mark of 70% or more. Okay. Probability. What would you put at the bottom? How many quizzes? 1, 2, 3, 4, 5, 6, correct? That's always your total. Make sure the bottom is always bigger than the top. Okay? So which tests are 70 or more, folks? 7 out of 10 is 70%, right? This is more, not, right? So this one is not good, not good. You're 40%. This is 80%. This is 70%. So 1, 2, 3, 4. 4 out of 6 is going to be your answer there. You're done. Don't reduce it. Don't turn it into a decimal. You just leave it like that. Next. Look at this. I hope that you can all nail this one. Yes, everyone's an exam will have 1 or 2 that are like easy. Just do it, right? 2 marks for this page. 63% as a fraction and as a decimal. 63 over, well, how many zeros is a percent? 2, right? So it's 63 over 100. And if it turn that into a decimal, just go 63 divided by 100, that's 0.63. There we go, 2 marks. Are you kidding me? No, that is off. That happens more often than you think. Okay, now pay attention. 4 marks on this one, so you know there's going to be a lot to it. 3 marks for the first question here. A company wishes to advertise a new type of breakfast cereal by sending out small samples through the mail to potential customers. There's a 7% chance that a potential customer will like the cereal and buy a full box for $6. There's a 7% chance that the customer buys and gets $6. Calculate. I hope you have this on your study sheet. The expected value. That should ring a bell. That's EV, not electric vehicle, expected value. Okay. If the samples cost 40 cents each to produce and distribute. So you might think this is not a game. You've always done games, Mr. Erickson. This is not a game. Technically, it is a game. It is a gamble for them, for a company to advertise. So at least you should think, okay, expected value. You will get the probability of winning. You will multiply it by the prize that you would win as the company minus the cost, like what did it cost to produce it? And there's no other way of winning, right? So therefore, we go straight to probability of losing times whatever the cost was. 3 marks here, so you have to be careful what you enter. What's the probability of winning? There's a 7% chance that a customer buys it. So we're going to go 7 out of 100. If the customer buys it, technically the company gets a prize of $6. But how much did it cost the company to make the samples and send it out? 40 cents. There should always be a subtraction here in this bracket, always. minus, what would go over here, folks? 93. 93, because if 7 out of 100 is a win, that means 93 out of 100 is a loss. So they didn't give you that. You had to figure this out. Times what it costs you to play. This is 40 cents, right? The 40 cents. So the 40 cents shows up twice here. Here it's just by itself. Here it's subtracting. So let's clean this up. 7 over 100 times, what is this, 560? Minus 93 over 100 times 0.40. And you should grab your calculator and actually calculate this, not just watch me do it, because this is where oftentimes the wheels come off. 7 divided by 100, I'll figure that out, times 560. That's 0.392 minus 93 divided by 100 times 0.4. That's 0.372. And at the very end, you put a dollar sign, okay? Don't forget that. So it's 0.392 minus 0.372. It's very small, but it's there. $0.02. And I know that they do this purposely sometimes because you're like, yeah, I shouldn't play because it's so little. It's like it's not worth it. That's not what you're supposed to say. It says justify whether the company should try this form of advertising based on your answer in part A. Justify. And you should say, yes, they should try, since the what? EV is positive. That's what the province would look at, whether you're saying positive or negative. So if expected value is positive, you should play. If expected value is negative, you don't play. Okay? So make sure you make a reference. So let's say you made a mistake in the first one. It's a completely wrong answer. You get a negative. If you then say, no, they should not play because the expected value is negative, you still get this mark here. That's why I would say never leave anything blank. Just go for it, and let's score some partial marks here. Okay, let's keep going. Oh yeah, I'll give you 2 minutes to this one. It should be less than 2 minutes. 1 mark. State the probability of a baseball hitting a ball if the odds of the event are 1 to 4. Could you do that? You want me to tell you the answer that I would not be happy with? Always when you see odds, add them up. So your bottom should be 5. Okay, so this is now you're close, right? And because it's in favor, it's 1 over 5. That's what we're supposed to write there. So odds to probability. I don't know, I will go A to B. If you want to get it to probability, you go A over A plus B. That's your safest way to write it. Okay. I would have this somewhere on my study sheet. If you want numbers, just come up with numbers. Like 2 to 3 would go 2 over 2 plus 3, which would be 2 over 5. Okay. Something like that. Continue. Ten cards numbered 1 to 10 are placed in a bag. A student pulls a card from the bag, records the number, puts the card back in the bag. The student repeats the process 9 more times, the table below shows the results. State the experimental probability of a student pulling out a card with a number greater than 7. Why do we call this experimental probability? It's based on experiments, right? What actually happened. That's what experimental probability is. So that's why they state it that way. So I hope it doesn't throw you off. But the probability here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It happened 10 times. And 7, what is it? Number greater than 7. So scan. 1, 2, that's it. It's just 2 over 10. It doesn't say 7 or greater. It says greater than 7. So you have to be careful which ones. State the theoretical probability of a student pulling out a card with a number greater than 7. Theoretical. This is what should happen. That's actually the more accurate one, guys. The theoretical is always the more accurate. How would you write the theoretical, folks? What do you base it on? What you have available. What do you have available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It says you have cards 1 to 10 like lined up like that. So probability here would be still out of 10, but greater than 7, you've got 3 options there. So it'd be 3 out of 10. There. What should one do to have these answers be closer to each other? Because they should be close to each other. Increase the number of trials or increase your sample size. You can say draw more cards, draw way more cards, like 100 or 1,000 cards, and all of a sudden these two will be closer to each other. One last one here for probability. Choose the letter that best completes the statement. The probability of a tadpole surviving and becoming an adult is 90%. What are the odds against this happening? Well, probability is 90 over 100, correct? Turn your percentage into a fraction if possible. Odds would be, how do you do odds, guys, from probability? In favor, you would go 90, and on the other side, what would you put on the other side? 10, exactly, because you would go, you take your total, subtract 90 from it. So it's 90 to 10. This is in favor. What about odds against? I think there's, yes, 10 to 90. That's right. And let's look for 10 to 90. It's nowhere to be found, is it? Whenever you can, like on this scenario, you kind of have to know how to simplify. We just divide both sides by 10. So that gives you 1 to 9. Okay? So this is the one you're after. So A is your answer there. Okay. I'm going to stop there.